we are back now and we are gonna start on number 8. So let's see. So is this even, odd, or neither? So how do we know if this is even or not? Well, this is the rule that you need to know. So even is when a function has symmetry about the y-axis. That's all you need to know. So do you see how this graph has symmetry about the y-axis? So this axis, this is the y-axis, and you can tell how this graph looks the same here and how it looks the same here. So if you see how the graph behaves in the same way, like the same patterns, then you can tell that there is symmetry about the y-axis. Also, if you want to prove it like mathematically, this is how you prove it, but I don't think you have to do it right now. So for now, just knowing that even means symmetry about the y-axis, that's all you need to know for number 8. Now, number 9 is gonna be odd. Why? Well, an odd function has symmetry about the origin. So you can tell this is how the graph begins here. So it goes from here, and then when it gets here to the origin, right? Instead of going back this way, right? Instead of going back that way, now this graph just shifts down here. So you can tell how the only symmetry that you have is only at the origin. Other than that, there is no symmetry about the y-axis. So if there is no symmetry about the y-axis, that means it's going to be odd because it only has symmetry about the origin. Also, if you want to prove it mathematically, this is the way you do it. But again, I don't think you have to do it at this point. But not for now, but save that for later. So number 10. So what you have to do here is you have to find local maximum, right? And then what's the local maximum? There you go. So this graph you can tell right away, at least the way I do it is I just look at where do I start and where do I end. This graph will never end, and because that line keeps going that way, so it will never stop, and then this line keeps going this way, so they will never come to a stop. So what that means to me is that any values that I have in between can be either a local maximum or local minimum. So the points that are like down the hill, those are going to be the minimum. The points that you have up here are going to be always your local maximum. So these are the different choices that you have. The only ones that make sense here is going to be B, because when x equals 0, right, when x equals 0 right here, then y equals 3, right? That makes sense. When x equals 0, y equals 3, so this is what sentence B is telling you. For example, number A says that when x equals 3, the local maximum is 3. So when x equals 3, my y does not equals 3. You see it? When x equals 3, my y equals 0. So that one makes no sense. So A is wrong. And then F and D will all be, C and D will be wrong. So let me give you another example right here. So this is another graph. This graph, as you can tell, it keeps growing this way, and then it keeps getting smaller or going downwards this way. So this graph will never come to a stop. That means that any number that you have in between those two lines is going to be either local minimum or local maximum. So right away, these are the points that you have down the hill. So they mean these are the local minimum, and then the ones that you have on top of the hills, those are going to be your local maximum. That's how you can know whether it is local minimum or local maximum. So moving on to number 11. So you have to find the absolute maximum and also the absolute minimum if those values exist. So it's going to be C. It's going to be C again. Why? Well, because when f equals 5, that means y equals 6. And when f equals 2, when x equals 2, then y equals 1. So when x equals 5, my y equals 6. And you can tell this is the point that you have all the way up here. So this is going to be your absolute maximum. And this one here is going to be your absolute minimum. Now, how you can tell it's going to be absolute and not just local? Well, if you can tell, this graph starts here, but it also ends here. So this graph will never keep going up or down. So this graph starts here and it ends here. When you compare that graph with the ones that I showed you a few seconds ago, you can tell this graph keeps going up, going up. This one keeps going up, and it keeps going down here. So these two graphs, they will never stop growing or getting or going downward. Instead, this graph starts here and it ends here, so it will not move. So that's why you know this is going to be the highest point and this is going to be the lowest point on the graph. So number 12. So if you want to graph number 12, this is what we call a piecewise function. The reason why is because you have like multiple functions being combined into only one. So this is what we call a piecewise function. How do we do this? So you first have to read like line by line. This is one function and this one is another function. So the way I always do it is like I like to take the value that I'm being given here. So I'm gonna replace this x with 2. When you do that, so f of 2 equals negative x plus 3. I'm going to replace my x by 2. So it's going to be negative 2 plus 3 equals 1. And that means that my point is going to be at 2, 1. Now, notice how I have these two, and I have a parenthesis in front of the 2. That means that value, I'm going to use it, but I'm not going to include it. Again, the reason why is because here I only have the greater less sign, but I don't have the equal sign. If I had it, then I will include it. But since I only have the sign that tells me that x is less than 2, I'm not going to include that value. So what I'm going to do is I'm going to draw here like an open dot. You can tell it's going to be an open dot, and I'm not going to close that dot. So this is going to be 1 point, and then if all the x's are going to be less than 2, just pick any point or any value that is less than 2. This time I wanted to choose 0 because it's less than 2 and it's actually easier. So when you replace x by 0, that will give you 3. So my point is going to be 0, 3. And this point I can use. These points you can definitely use it. So if I try to do it, it's going to be at 0, 3. So it would be 0 and then 3 units up. 1, 2, 3. So right here it's gonna be my point, and then all I have to do is just draw a line that connects those. That's all you have to do. Just draw a line, and that's it. That's how you do the first part. Now for the second part will be the same thing. Just look at the values. Your values are gonna be greater equal than 2. So I'm gonna start at 2. So when you start at 2 and you replace them, you will end up with 2, 1, and then just use any value that you want as long as that number is greater than 2. So this time I wanted to use 5. So my point will be 2, 1 and 5, 7. Now keep in mind that these two values, you can include them, so they are going to be part of your final answer because they are greater equal. So you have the equal sign down here. So what happens is that since I have a point at 2, 1, so this is, instead of going to be an open dot, now I'm going to close the dot because these points is telling me that I can use that point. So I'm going to close it, and that's going to be my first point, and my second point is going to be at 5, 7. So it's going to be 5 units here and then 7 units up. So it's going to be somewhere around here. And then all you have to do is just draw another line to connect those two, and that's it. That's how you know that this graph is gonna look something like that, just like that. Now for the for 13 and 14, those are pretty simple, so make sure that you understand how they work. So number 13, it just they're asking you to shift that that equation 4 units down. So this is how you shift that that equation 4 units down. This is how you shift the equation 4 units up. For number 14, it's kind of a little bit more confusing for most people, but I think with all the different options that I gave you here, it should be easier for you. So shifting that graph 9 units to the left, this is how you do it. Y equals the square root of x plus 9. If you want to shift it 9 units to the right, instead of positive 9, it's going to be negative 9. If you want to shift it up, then just write the 9 outside of the radicand, and if you want to shift it down, just write a negative 9 outside of the radicand. So Whether you write that number under the radicand or outside of the radicand, it means a lot. So based on what I gave you here, based on these four different options, can you guess? These are the ones that I gave you. So let's just take a look at the first one. So x plus 3, and then I have this negative 2 on the outside. So if I have a positive number inside of the radicand, then that means what? That means 3 units to the left, right? 3 units to the left, and then 2 units down. If I have a negative 1, then that means 1 unit to the right, 1 unit to the right, and then 7 units up. This one means 3 units to the right and 5 units down. So I hope that helps. It really is not that bad, but you just have to make sure that you understand how a graph that has a radicand works. But again, I hope with that you can understand it. So see you in the next video, guys.